Alright guys, since we have notes now on this angle challenge, let's go ahead and let's just talk about how we can use those properties that we just talked about and you wrote down to help solidify how to use facts and relationships to find unknowns. And that's the puzzle of mathematics. It's kind of the challenge and the fun of it. So see if you can figure some stuff out. Now I'm going to go between GeoGebra and my Smart Software. Smart Software is where I'm going to put the answers and do some additional marking, I'm sure. But I'm going to use GeoGebra as well and like the polygon tool to help us visually see triangles, quadrilaterals, and things in this diagram. Because when I look at this thing, I think about how busy it is and how hard it is to kind of focus on certain things. But once we can see how to isolate objects from a busy diagram like this, and then it makes these problems a little more accessible, and meaning that you can actually solve the problem. Okay, so let's get started here. The letters here go from A to M. We don't have to find the angles in order, but that's a good place to start, right? Maybe we start at A, because since it is A, it might be the first one we need to find. But let's not stick to that, okay? So A here, if you look at A, they tell us, oh, and before we get going on A, let's look at what the diagram's actually showing us here, okay? We have some congruent marks, and we have this little symbolic thing here. So and means that we should probably know what this means, right? Because this is happening, whatever that means, and this is happening. Okay, the L's, those are just cursive L's. They mean line. So we have 4 lines in this diagram. Line 1, 2, 3, and 4. So line 1, line 2 are these 2 horizontal lines. These symbols here mean parallel. So that's just short mathematics symbolic form of parallel. So 1 and 2 we know are parallel. So those angle pairs, whenever you hear parallel, you should have a little flag in your head that pops up and goes, parallel lines, angle pairs. I need to know, probably be aware of my corresponding alternate interior, alternate exterior, and same side interior angles. Okay. Also 3 and 4 are these diagonal lines up here. They're parallel to each other as well. So whenever you see something like this, this is what we call given information. Okay, it's given to us that we know this fact. All right. Now let's also look at our angles here. Oh, let me say something too about parallel lines. If you ever look at a diagram, they can give you the information by writing it out like this, so we can just read it and go, okay, these 2 lines are parallel, and these 2 are parallel. We get to take that for truth. We know that that's going to be true. Now, if they didn't write it this way, you might see diagrams that have arrows on the line, like this and this, for instance. So symbolic, just like these angles right here, based off their symbols, we know that this angle H is going to be congruent to this unknown angle right here. Also, this angle 70, that's 70 degrees, is congruent to this angle J. And knowing that, we automatically know J is 70. So there's one of our answers, by the way, as we kind of talk and think. That's easy. J is 70 degrees because we know the congruent marks. It's telling us that they're congruent to each other. Okay? Let's see. And segments have the congruent marks too, right? Like this segment is congruent to this segment because of the same marks. So we use these arrow marks to show parallel as well. So if you ever see a diagram and you see lines that have matching arrows on them, and since those are parallel to each other, and I want to mark that these are parallel to each other, I'm just going to do 2 arrows, right? So we know that this line and that line are parallel to each other. So written out or symbolically, we need to know, okay, those lines are parallel to each other. I get to use that fact. All right. Now let's go ahead and go back to A. So J being 70, we might be able to work some angles over here, right? Let's go ahead and start looking at A. So I'm going to use, I'll just use this blue pen here. We know that this angle next to A is 52 degrees. And if I look at this, I think of A and 52 as a linear pair. So if you add up 52 and we add up A, aren't they going to add up to make a straight line here, right? Of 180 degrees. So that's a linear pair. So we need to be able to take 180 minus 52 and know that A then is going to be 128 degrees, right? Because 128 plus 52 is 180 degrees. So we know that this is 128. So I'm going to write it on my diagram. You might want to write it on yours too. The more we know, it's easier to just look at it and be able to jump here. B is sitting right here. A is right here. So notice we have parallel lines here. This line right here is considered a transversal. It's crossing both parallel lines here. So A, this angle, and B, this angle, and our two parallel lines does not look a whole lot like our parallel stuff we've been talking about. So isn't A and B alternate interior angles? So also known as congruent to each other based off of their relationship. Okay, so we know that B has to be 128 degrees also because it's an alternate interior angle to A. Okay, look at C and B. Again, linear pair, right? B plus C makes a straight line. So this is 128. So C, oh, I've seen that before. C must be 52. Oh, hey, look, this 52 and C, aren't they alternate exterior angles to that parallel line thing that we were just looking at, right? Another angle pair. So either we could think linear pair here, so C has to be 52 degrees, or we could identify C and this angle that's already 52. They're an alternate exterior angle, so therefore, therefore they have to be congruent. I said oops because my C went away, but this is 52 degrees, right? So we know that this is 52 degrees. Okay, let's take a look at D. D and C, how are they related? Okay, I'm going to go to GeoGebra here for this one, see if you can see this. I'm going to use my polygon tool. Maybe I'll make it red. I'm going to look at C. We just said, excuse me, I'm going to get my pen tool, that C here is 52 degrees, right? We know that. So now, let's look at D and C. They're two angles within this little triangle here. Do you guys see that, I hope? So I'm going to make this stand out. So there's this little triangle that I'm looking at here. Okay, so this 52, hey, this is the base, CE, because it's the side that's not congruent to these two. So then this angle that's 52 and this angle here, we don't know what it is yet, but we know that that has to be 52. Right, because they're the same thing. So I'm going to just write 52 here and say that it's this angle. So if that's 52 and that's 52, we know 2 out of the 3 angles in our triangle add up to 104, right? 52 times 2 is 104. Therefore, D is the third angle in that triangle. So to find D, we would just take the angle sum, that 180 again, subtract 104 from it, we get 76. So D must be 76 degrees. Okay, so D is 76 degrees, and I'm just going to undo everything that I do in this video so that when we come back, we don't have too much stuff here. Maybe I'll keep the angle measures though. That's 52. This is, what did we say? 52 was 104, so this has to be 76, we said, right? 76 degrees. Sorry, that's a mess, but we should know it as we keep working. So D is, oops, and I left D out. Let's put D here. D has to be 76 degrees. So this is 76 degrees. Okay, next letter, E. Well, we got parallel lines here. If we try to think about angle pairs, this D and this E, I don't really identify them being any kind of angle pair, you know, like corresponding or anything like that. So if I look at E though, the angle that I do want to find, and I have my two, you know, parallel lines transversal, this angle here and this and E, aren't they same side interior angles? So we know that those two angles are going to add up to 180 degrees. And here's the first time vertical angles come into play, because if you look at this line here and this line here, they intersect at this point. So isn't D that we found out to be 76 degrees and this angle vertical? Therefore they have to be equal, right? So we know that this angle now is 76 degrees. So now that we know that this is 76 and we know D was 76, then we now know an angle in E, these two have to add up to 180 degrees. So E again, if we add 76 to E's value to get 180, doesn't E have to be 104? 104 degrees. That was weird that we just seen that angle in our angle sum up here. But anyways, E is 104. Okay, let's look at F. Well, E is on top of this line, F is below this line, and if these two lines now, this one here and this one here, oops, if they're parallel to each other, we know that, right? If they're parallel to each other, and we can think of this line now as a transversal to these two lines. It's crossing both parallel lines here. So E and F then would be an alternate interior angle pair. So we know that they're automatically equal. So F also has to be 104 degrees. Okay? So we know F now is 104 degrees. Okay, let's look at G. Well, G up here and F, if I look at the diagram here, F is obtuse, it even looks obtuse, it's 104 degrees. G looks acute, right? So it doesn't look like they're going to be the same measures, so we can't just go, oh, G must be the same, because they don't even look like they're the same. But I bet you they're supplementary. And let's think about this. So this angle F and this angle right here are a linear pair. Therefore, this angle must be 76 degrees, right? And this angle now and G, aren't they corresponding angles? If we think about two parallel lines cut by this transversal, right? They're corresponding, so G must be 76 also, which is supplementary to F. So G is 76 degrees. Okay? Nice, we're just moving right along this thing here, and I hope that this is making sense as you kind of hear me talk and think out loud and see how our relationships are kind of working here, all right? Now here's something interesting. G, we've got this angle H, this angle here, they're congruent to each other, but we don't know what this is, so we don't know what H is. But here's something to consider. G, which is 76 degrees, and this angle right here that I'm marking in blue, if I add that to G, don't they add up to make 180 degrees? G plus this big angle must add up to 180 degrees. So wouldn't this big angle be 104 degrees? Because those add up to 180. Well, this big angle is made up really of this angle H and this angle right here, and they're congruent to each other. So really you can think of it as this angle measure plus this angle measure have to add up to 104, and they're congruent, meaning they're both the same thing. So if two numbers are the same number and they add up to 104, then don't both have to be half of this, because a half plus a half equals a whole? Or each of these angles must then be 52 degrees, aren't they? So H is 52, this angle is 52, because they're the same and they add up to 104. So check that out. We just used a linear pair concept and some congruent angle measure to reason that both of these angles must be 52 degrees. So H we know is 52 degrees. Okay, where's I at? Is there even an I? L. I don't see I up here. Maybe I just thought because it was in alphabetical order. Well, I'll just get rid of I. If we find it, we'll come back to it. Okay, so 52. Let's see what else we can do here. Well, we know that J is 70. These two lines are parallel. We can think of this segment as a transversal. J and M are supplementary because they're they're same side interior angles. So if J is 70, we have to think of M as the number that adds to 70 to make 180, so M must be 110. Okay? J and K are alternate interior relationships to each other, so we know that K also must be 70. Another way to argue that is that K and M make a linear pair, right? We have a line, two angles that add up to 180 degrees, so they're also 180. You could think that way as well. And now here's something to think about. Let's see, K we know is also 70. M we wrote 110. So we have L and we have N up here that we need to find. And we're done. Okay? So let's see. Notice this angle here is 70. This angle here is 70. And that looks a whole lot like our notes that we talked about before. In an isosceles triangle, the base angles are congruent to each other. So look at our diagram here. We have some triangle. Oops, excuse me. I don't mean to keep flipping around on you. We have a triangle here. I'm going to isolate this triangle now. In it, we know that its two base angles right here are the same because this is 70 degrees. So we know that they're the same. So these are what we call two base angles. That means that this side and this side would be legs, right? Because the base angles are the same. These sides have to be the same because this would be the base. Therefore, we need to find the vertex angle. Well, it's just a triangle, and we know the three angles add up to 180 degrees. So if this is 70 and that's 70, then these two angles add up to 140. Therefore, L must be 40 degrees. So L must be 40 degrees because of our isosceles triangle thinking there. All right, last one is this N here. How do we find that? Well, if we look at this again, isn't this a triangle as well? Right? And we know that this angle here is, let me look back, 52. So we know that this is 52 degrees. Okay? So this angle plus N plus this angle we know add up to 180 degrees. And we know that K is 70. And we have vertical angles, right? We have this line intersecting with this line. So 70, this must be 70 as well because of a vertical angle relationship. Okay, so we have 70 plus 52. You add those up, I think we get to 122. So if we take 122, we subtract it from 180 to find out what N is. Then we get N to be what? 122 minus, or 180 minus 122 is 58. So N is 58 degrees. And we found all the angles. So I hope that you followed along with that. I know I went relatively quick through that. I'm trying to keep the video down. I'm already at 16 and broke my 15-minute rule promise, so I need to quit this video. I apologize, but I needed that minute. So good luck on your challenge 2, which would be your submission for this quest.